Good morning, my YouTube viewers. What we're going to talk about in this video is sampling distribution, and I've got a program in Python that we're going to review the code on to cover that information. So in order to write this program, what we need to do is we need to import two libraries. So the first library is going to be NumPy as NP, which is the numeric library, and then the second library is matplotlib.pyplot as PLT, which is the visualization library. And then so now what we're going to do is we're going to set the parameters for the population. So the population mean is 50, the population standard deviation is 10, and the population size is 10,000. So now what we're going to do is we're going to generate the population. So the first thing that we want to do is we want to set our seed. And the reason why you set your seed is so every time you run the program, it will initialize to the same values. So you type in np.random.seed and you can put any number you want within the brackets. And now we define our population as np.random.normal brackets log equals population mean, comma, scale equals standard deviation, comma, size equals population size. So now we set up our sampling parameters. Sample size is 30 and number of samples is 1,000. So now what we're going to do is we're going to collect our sample means. So sample means is an empty list. And then we're going to create a for loop for underscore and range, num samples, and num samples is 1,000. So that means it's going to iterate 1,000 times. Sample equals np.random.choice, brackets, population, comma, size equals sample size, comma, replace equals false. So that means every time it takes a sample, it's not going to replace that sample. Sample means dot append np dot mean sample. So basically what you're going to do is every time the for loop iterates, it's going to append the sample mean to the list. So when the for loop has iterated through the number of samples, it should have 1,000 sample means in it. So now we're going to calculate the mean and the standard deviation of the sampling distribution. Sampling distribution mean equals np.mean sample means. Sample distribution sample standard deviation equals np.std sample means. So we've got the mean and the standard deviation of the sample means. So now we're going to print the results. We're going to print the mean of the sampling distribution, and we're going to print the standard deviation of the sampling distribution. So the mean of the standard distribution is 50, and the standard deviation of the sampling distribution is 1.86. So now what we're going to do is we're going to plot the sampling distribution onto a graph. So we're going to use matplotlib to do that, and we're going to create a histogram. plt.figure brackets fig size equals 6,4, plt.hist brackets sample means, comma, bins equals 30, comma, color equals light blue, comma, edge color equals black, comma, alpha equals 0.7. And we're going to put a vertical line in the histogram, plt.axv line brackets sampling distribution mean, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals mean. And then so the title is sampling distribution of the sample mean. The X label is sample mean. The Y label is frequency. You're going to get a legend. You're going to get a grid, and we're going to show it. So this is the sampling distribution of the sample mean. and you can see that the mean is 50, which is interesting because the mean of the population is 50. The mean of the population is 50, and the standard deviation of the population is 50. Sorry, the standard deviation of the population is 10. I made a mistake on that. The population standard deviation is 10. I made a mistake on that. But when we make sample distributions, the mean of the sampling distribution is 50, and the standard deviation of the sampling distribution is 186. So that just shows you there is a difference between the population and the sample. So that concludes this video. And the next video, what we're going to do is we're going to talk about central limit theorem. We've talked about it in the past, but we're going to go ahead and review it again so it can solidify in your mind. I hope you decide to watch that video.